All right, today we're going to be doing the logarithmic form. So first for your bell work, we're saying 2 to what power gives me 16. So if you do 2 to the power of 4, that gives you 16. So we're saying x equals 4 here. And if you had your perfect 4s, you would be able to do it. So here, when I say, well, 1 equals 1, so I'm saying 3 to what power is going to give me the 27 down there. So if I do 3 to the power of 3, that gives me the 27. So x equals 3. This right here, -5 to what power gives that to me? So if you didn't know, you can do -5. Let's see if it's a power of 3. Nope, that wasn't a big enough number. I know it has to be odd because it stays negative. So let's try it to a power of 5. Yep, that's the answer. So x equals 5 right here. And then this right here, to make 4 go on bottom, you're going to have to make it a negative. Remember, a negative flips your inequality, or flips your fraction. So it's negative, and then you say 4 to what power gives you 64. So if you say 4 to the power of 3, that gives you 64. So the answer is -3. And you could check, you could do 4 to -3, and then do 1 divided by 64, and you get the same decimal when you do those. So today we're going to solve logarithms and write equations in logarithmic form. So really the inverse of, instead of it being the opposite, it really should say inverse here. The inverse of an exponential function is a logarithmic function. And we call b is called the base of the exponential and a of the log. So right here, so there's your base, and then if there's no b, we always assume it's a 10. So like my calculator right here, if I type in log, that's ln. If I type in log, there's no base. It's assumed base 10 when that happens. So all we're going to do is we're going to rewrite into our two different forms right here. So these are the just different forms. So this right here matches here. So 32 is my y, and 2 is my base, and 5 is an x spot. So I'm going to rewrite it using this form. So it says log, I'm going to put the b down here, so that's the 2, and then it says put the y next, that's the 32, and then it says equals, and put my x over here. My x was 5. So again, you're just matching it up. So this is your y, 5 is my b, and 3 is my x. So you're just putting in right here. So it says log with a little b. So log, my little b is a 5. It says y is next, so 125. And then it says equals, and then put my x. All right, so here we get log base 4 of 64 would equal 3. And log base 5 of 625 equals 4. I'm just matching them up right here. So now we're going to do the exact reverse of this. So now this is the b. I'm given this information. So here's your b, 49 is the y, and 2 is the x. I'm just matching them up in each spot. So now I'm going to write it this way. I'm going to put y equals b to the x. So y is 49 equals my b, 7, to the x, 2. And it should be making a true statement this time. So again, this is the b, the y, the x. So b to my x equals y. Remember, when nothing's written for log, we're going to use a 10. So it's 10 to a power of 2 equals 100. And then 6 to a power of 4 equals 1296. So down here, what we're going to do is we're going to pretend this equals x, and we're going to rewrite it, and then we need to solve to see what it is. So I'm going to say 3 to what power gives me 81? So 3 to what power gives me 81? And we already know what it is because it's right here. But if you didn't know, you would just have to guess in your calculator. So x equals 4. So I'm going to rewrite it. 4 to what power gives me 16? So that is 2. So x equals 2. Now this gets a little tricky here. So you're saying 9 to what power is going to give me 3? And if I do 9 to any whole number, it's getting bigger. So that tells me it has to be smaller. So if I did like 9 to like a 0.3, that doesn't give it to me. If I do 9 to a 1/2 power, that means square root. So you guys remember, so a square root is the same as a 1/2 power. So really, so 9 to what gives me 3? And that is 1/2. Another way I like to think of this sometimes is like this. I'm going to take a pencil. Is if I said 3 to what power gives me 9, and then I flip it. So 3 squared gave me 9, so the answer would be 1/2. So for example, if the question said 16 to what gives me, I'm going to try even harder one. I'm going to say 64 to what gives me 4. Well, I don't know, but I know what 4 to what gives me 64, and that would be 3. So 4 cubed gives me 64. So over here, my answer is a 1/3. I just flip it. Becomes 1/3. So a little trick there. All right, so I'm going to let this equal x. Go back to my pen. So 2 to what power gives me 8? And that is going to be 3. Just a little base. We did all logs here, but there's also something called the natural logarithm, and then that's the ln. So the difference here is that if we have any number like 3 to the x equals y, then we're going to have log base 3 of y equaled x or something. Those are inverses. Well, that's not inverse, but these would be logs in exponentials. But if I have a natural logarithm, like natural log of x equals y, the base down here is an e. So I'd say e to the y equals x. These are the rewriting forms of these, right? So we're rewriting these e to the y. So the base, remember I said up here, if there's no number for log, our base is 10. So if you ever see an ln, its base is the number e. And it is a number in your calculator. You can find it. I do right here. There's e to the power of 1. You can see e is an actual number. So that's what this is here, the base of natural logs. So logs and natural logs are the exact same. It's except that the natural log has a base of e, and every other number in the number system belongs to log.